in this lecture I will be talking about colloids. Uh, Colloids are something which you can say are in between a solution and a suspension. You can define a solution by a homogeneous mixture for example, sugar in water, whereas you can define suspension as a heterogeneous mixture. And the example is sand in water. You basically get precipitates in suspension, whereas you don't get any precipitates in solution. A colloid is actually in between these two. That's how you can define colloid. It is neither a solution, it's neither a suspension. In other words, the suspended particles are so small in size that it is close to solution but not exactly a solution. So size between the particles, they vary between 1 to 1000 nanometers, that is 1 micron. This is the size of the particles, and as I said, the particles are invisible. Invisible to the naked eye. And the second characteristic is they remain suspended. They don't fall as precipitates. Now, in a colloid, as it is something between a solution and a suspension, there is a continuous phase which is called the dispersion medium. And there is a discontinuous phase. It is called the dispersed medium. At least, and as I have told you, the dimension should be between 1 nanometer and 1 micrometer. And another properties of a colloid is they are thermodynamically unstable. and they have a very high surface area. Now, some examples of colloids. As follows, they are like liquid aerosol, then foam, emulsion, sol, etc. Now, interaction between molecules of one substance with another almost always in high energy than the interaction of one surface with itself. So, self interaction, the energy is always less than energy between energy associated with interaction between two different molecules. Uh, Therefore, a system will always move in such a way to eliminate unfavorable interactions, happening to eliminate surfaces. System, as it always tries to be in equilibrium, and thus it will try to remove unfavorable interactions, and the most unfavorable interaction takes place on the surface, so it will always try to uh, eliminate the surface. And this elimination of surface will occur when the particles stick together. So it implies that the particles will try to coagulate. Or you can say the particles. So basically, there are three things that can happen. Either it's coagulation, or it can be something called flocculation, or sedimentation. Now we need to actually have a control over all these things. That is what colloidal science is all about. And the stability of colloids, that means we need to avoid this coagulation. And so there has to be some stability associated with it. And the stability is achieved. Stability in colloids is achieved if we somehow cause repulsion between the particles, and this repulsion will be possible by two methods. One is it can be electrostatic repulsion, or it can be a static repulsion. Another aspect is water in most surfaces are electrically charged. Water, most surfaces are electrically charged due to adsorption of an ionic surfactant from the solution. Adsorption of ionic surfactant from the solution, or it can be due to surface ionization due to surface and acid-base reactions. Surface and acid base reactions. For example, SiOH breaking up into SiO minus plus H plus. So at neutral pH, most oxides have negatively charged surfaces. Most oxides, they are negatively charged surface. Now, there can be three different solubility of cation and anion in an insoluble salt. So, consider an insoluble salt. So there can be three different solubility of cation and so it can be, so the three different solubility will continue here. The first one will be the charge induces an electrical double layer. So induction induces electrical double layer by the charge, and there can be repulsion between atmospheres of charged particles. Repulsion between charged particles Okay, and there can be some addition of salt may cause some destabilization. Because particles can approach each other and coagulate. Now, whenever we are talking about two like surfaces, two likely charged surfaces, they will repel each other. For example, you have a surface like this with negative charges initially surrounded by positive charges. This is one of the particles. This will be repelled by a similar particle having positive charges. Initial negative charges followed by positive charges. So there will be a repulsion between these two, and there is a range of such repulsion, and that range is called Debye length. It is given as K T to the power inverse, and it is equal to 0.304 divided by root over the salt concentration. So that means if we have 0.1 molar NaCl, for that the Debye length becomes 1 nanometer. Now, based upon this repulsion, we have a rule. It's called Hardy-Schulz rule. According to Hardy-Schulz rule, flocculation is controlled by valency of the counterion. Flocculation is controlled by valency of the counterion. That means there will be fewer 3+ ions then 2 plus ions, then 1 plus ions, needed to cancel out colloid charge. Needed to cancel out a colloidal negative charge. We have another repulsion. This is basically this is we talked about two types of repulsions. One is electrostatic, and in my previous lecture. So repulsion, as I have told you, this repulsion can be of two types. One is electrostatic repulsion. So the above phenomena is associated with electrostatic repulsion, and we have another type of repulsion called steric repulsion. So we'll try to understand what is a steric repulsion is now, or you can also call it a steric stabilization. So steric stabilization. Now what happens here is that the colloid surface is coated with an adsorbed hairy layer of polymer. Colloid surface is coated with an adsorbed hairy layer of polymer. So this is basically a short range repulsion. Short range, and the repulsion is proportional to one by 10⁸. So what you have here is these are two colloidal particles. What we have done here is we have coated it with some hairy polymers. Now these hairy polymers will repel each other, and we need to have solvent flowing in, so this will add up to the repulsion. Now the reason this repulsion occurs is that polymer chains together are unfavorable. So polymer chains together have very high entropy. So we can say that it is entropically unfavorable. And increasing the concentration of chains between the particles induces osmotic pressure. So if it increases the concentration, the higher is the concentration of the chains. That means if we increase the concentration, we keep on adding more and more concentration. What will happen that the nearby solution will try to go into this due to some osmotic pressure. Got it as osmotic pressure, and there is how the solvent will flow in, and the volume occupied by the polymer changed by varying the solvent. So you can have a change in solvent, or you can cause a change in temperature. So these two are the tuning parameters by which we can have a control over the amount of solvent or the amount of repulsion that is taking place between the colloidal particles. Now, there are certain factors which can influence the flocculation or coagulation. So factors that influence coagulation or flocculation. The first one is temperature, that is heating. It will increase the velocity of the colloidal particles, and they will collide with enough energy. So particle will be have high velocity. So that is how, and with the high velocity they have enough energy, so the energy barriers will be penetrated. Energy barriers, they are overcome or penetrated. So this is detrimental. So heating will not give a good colloidal solution. The second is stirring. Stirring, also like heating, will increase the velocity of the particle, and they will again have the same effect of overcoming the energy barrier, and they will coagulate. And the third factor is changing the pH. Change the pH of the solution. So what it can do is it can flatter or dissolve the electrostatic stabilizers. That means if you change the pH, the polymers which are attached or which are adsorbed on the surface of colloids, they can get dissolved. Okay, so desorption may take place, so that will again enhance coagulation. And the fourth one is if we add an electrolyte. Additional electrolyte, it will neutralize the surface of the particle, and neutralize particle surface. So again, coagulation, the electrostatic repulsion that was initially present will be hampered, and there are chances of coagulation, and ultimately it can also cause settlement or sedimentation. So these four factors are responsible for coagulation of particles, and we need to avoid these four parameters if you would like to have a good colloidal solution, a colloid.